Hi, Sky. So I wanted to answer your question, and I'm going to actually approach it two different ways. The first one using the distance formula, and the second one using a little bit more math logic and the Pythagorean theorem. So let's get started. With the distance formula, the first thing you want to remember is that it's just a modified version of the slope equation, which is also a modified version of the equation of a line. So looking at the distance formula, we've got d is equal to the square root of x2 minus x1. Oops. There we go. Squared plus y2 minus y1, also squared. Not doing a very good job as much as okay. And so we're given these vertices of the triangle, which I circled in red. I'm going to put those on the board. So I just made us an XY axis. So we have 0, 7. So remember, everything is XY. So 0 for the X, 7 for the Y. So that is our first point. We're going to label it S for Sky. Then we have 6, 7. Put our K there, and then 3, 0. We'll put our Y here. So then what I'm going to do is I'm going to go ahead and connect these dots. 6, 7, and 3, 0. Okay. Now notice, if we break this large upside down triangle in half, we have right triangles, right, in the middle, equidistant apart because that line bisected the two, it bisected the 6 units on the x-axis. So we know that each of these sides are 3. And we already know the height of the triangle as 7, since that was given to us as the coordinate 0, 7. So what we can do is we can just plug any of these points into the distance formula. So I'm just going to take the s and the y since they're right there. And I'm going to go ahead and I'm going to plug in pink the x coordinates. So x2 I'm taking from the 3, 0. So our 2 is 3. And our 1 is 0. That's that squared. Plus our y2, which is 0. And our y1, which is 7. And that is also squared. It's just right on top of the numbers there. So let's go ahead and simplify this. So 3 minus 0 is 3. We square that, and we get 9. And then we want to add in 0 minus 7, so negative 7 squared, which is 49. We combine that and we get square root of 58. Now, that square root of 58 tells us that the distance from these 2 points, which I just marked in yellow, is the square root of 58. So we'll label that x. Now, to find the perimeter, we want to take all 3 sides of the triangle. We have 2 sides which are the same, so 2 of those, which are square root of 58. And then we're going to add in the third distance, which is 3 and 3, which we know because that x coordinate there was 6. So we're going to add in 6. Now, when we plug this into the calculator, we get approximately 21.23 units. Okay. Now, the other way that you could look at this problem very quickly is just by using the Pythagorean theorem. And so I'm going to erase the distance formula up top. And I'm going to show you, remember, the Pythagorean theorem is a squared plus b squared equals c squared. And again, we can break this larger triangle into half, and we then have two right triangles. So looking at the height of the upside down triangle, that is 7. And then the hypotenuses are x, so that's what we don't know. So we'll leave that as the unknown. And then we have the base, which is 3. So we have 3 squared plus 7 squared is equal to x squared. And again, that gives us 9 plus 49 is equal to x squared. And from there, we want to take the square root of both sides so that we are then left with x, which is equal to the square root of 58. And again, that's the x that's on the hypotenuse angle. And so we would have 2 of those, so square root of 58 plus square root of 58 plus that very long base of 6, or in other words, 2 times square root of 58 plus 6. You may see it written as 6 plus the square root of 58, so that way you can leave your radicals in the end. If you want an exact answer, that would be it. Or you could then round it by using the calculator and get an approximation, and to the hundredth place, it would be 21.23 units for your perimeter. Hopefully that answered your question.